The name of Allah who is most merciful and beneficent. Assalamu alaikum students, hope you are doing well. This is an OSP round 2 and welcome to your chemistry class. Today our topic is about isotopes of chlorine and uranium. Here's the content which we are going to discuss in this video tutorial. It's about isotopes of elements, radioactive isotopes, isotopes of chlorine and the isotopes of uranium. Before going to start this, let's revise our previous concept about the isotopes. Atoms having same atomic number but different mass number are called isotopes. But why we need them? Radioactive isotopes has a great medical significance. They can be used in food preservation for a long time, archaeological dating and medical diagnosis. For example, iodine 131 is used for the treatment of goiter, and many other radioactive isotopes are used to locate the position of tumor or cancerous cell in the body. Here's the isotopes of chlorine. Chlorine has two isotopes, chlorine 35 and chlorine 37. Both these are the stable isotopes of chlorine, and you may pronounce it as Cl35 and Cl37, and they are used to study the toxicity of environmental pollutant and are usually supplied in the form of NaCl. If we look at the structure of these isotopes, then we will find that both these isotopes have the same number of proton, but their number of neutrons are different. Like in Cl35, number of protons are 17 and the number of neutrons are 18, but the atomic number of Cl35 is 17. Similarly, in Cl37, the atomic number is 17, but if we look at the mass number, then the mass number in which the number of protons are 17, but the number of neutrons are 20. So the mass number of both these isotopes are different with each other. Here's the abundance of these isotopes in the earth crust. Cl35 has a huge abundance of about 75.77%, while the Cl37 has an abundance of about 24.23%. Here's another isotope of chlorine, that is Cl36, but it is actually the radioactive isotope and has a half-life of about millions of years. If we look at the atomic mass number of chlorine, it's actually 35.5, not 35, because when we are going to calculate the atomic mass, we are supposed to take the average abundance of these two isotopes, and when we calculate the answer, then it concluded that the answer is 35.5, not 35. That's the reason chlorine has an atomic weight of about 35.5. Here's the detailed structure of these two isotopes, Cl35 and Cl37, and the abundance of these isotopes also mentioned here. Now come towards the isotopes of uranium. Uranium has three isotopes, uranium 234, uranium 235 and uranium 238. All the isotopes of uranium are actually radioactive in nature, but uranium 235 is used as a nuclear fuel. The nucleus of uranium 235 atom comprises 92 protons and 143 neutrons, and when we combine these two values, 92 plus 143, it comes out 235. When the nucleus of a uranium 235 atom captures a moving neutron, it splits into two and releases a tremendous amount of heat. And the heat generated by splitting the nuclei of uranium 235 atom is then used to make steam, which spins a turbine to drive a generator thus producing electricity. Here's the chain reaction in which when the neutron collide with the nuclei of uranium-235 is split into two, and that nuclei when hits the rest of the atoms nuclei of uranium, it releases the tremendous amount of energy with the generation of free neutrons. These neutrons are actually captured by the barium rod to slowing down the reaction. Here's the uses of isotopes. As we know that isotopes has a great medicinal significance, that's why we use these isotopes in our daily life. For example, cobalt 60 is used to arrest the development of cancer. As we discussed earlier, iodine 131 is effective against goiter. Similarly, carbon 14 is used for the age determination of all objects, and also used in a breath test to detect the ulcer causing bacteria Helicobacter pylori, as we discussed earlier. Similarly, cobalt 60 or cesium 137 is used to kill a lot of microorganisms in a variety of foodstuffs. Moreover, titanium 99 is used to image the different body organs like brain, heart, liver, lungs, etc. The last but not the least, actually the carbon 11 or fluorine 11 is tumor identification. Like if tumor is developing in the body or in a specific organ, then we will use carbon 11 and fluorine 18 to identify the location of that tumor. Here's the work that should be done on loose sheets. The first question which you have to done on your loose sheets is actually the isotopes of chlorine. You have to draw the structure of these isotopes. The second question is actually the difference in these isotopes. Third, you have to find out the 5 more uses of isotopes, and the fourth one, you have to write a short note on uranium. This is Ubaid Hussain signing off. Allah Hafiz.